Hello everybody, today we're going to talk about electronic configuration and valence electrons. So to understand the basis of biological mechanisms and the formation of organic molecules in our body, we need to understand first how electrons behave inside the atom in order to make bonds. So the first thing that we have to know is the electrons, how the electrons move around the atomic nucleus. So electrons move around the atomic nucleus following different levels of energy, or what we call on here shells. So this is a representation of the first shell, the second shell, and the third shell. So electrons can only move from the lowest energy level to the highest energy, depending of the electron's potential that they have. So from this region to this region is going to move depending on the potential energy. So this region right here is going to have the highest potential energy, and this region right here is going to have the lowest potential energy. So this region right here is called the outermost shell. This region is really important because only this region we're going to find all the electrons that can be shared or can be transferred for atom to atom in order to make bonds. The outermost shell is also important because the chemical behavior of atoms depend mostly on the number of electrons in this region, the outermost shell. So in order to predict how many electrons we're going to find on that region, we can use the following diagram, the one that I drawn here. So this diagram represents the different levels and sublevels of energy that the electrons are going to use to move from one place to another place around the atom. Sorry, the nucleus. So you see a bunch of numbers and a bunch of letters. So from the number 1 through 5, these values right here that represent the levels of energy. So the level, the number 5, has a high level of energy than the level 1. So this one right here has a high level of energy compared to number 1. So in the case of the sublevels, we have different letters from S to F. So S, the maximum number of electrons that we're going to have for a sublevel of S is 2. The maximum of electrons that we're going to have for a sublevel P is 6. The case of D, 10, and for F, 14. So following this diagram, we know that this region right here, we're going to have a higher energy subshell and level, and the ones that we have on here, we're going to have the lowest energy sublevel and subshell. So this diagram represents the way that the electrons are going to be filled, or the way that electrons are going to be filling the subshells in and around the atom, the nucleus, sorry. So let's work on the following example. Let's use sulfur. So we know that sulfur, the atomic number of sulfur is 16. So you know that the atomic number represents the total amount of protons that we have for each element, which is the same amount of electrons that we should also have. Why? Because remember that the atoms are electrically neutral, so they supposed to have the same amounts of protons and electrons. So if we start what we have on here in the diagram, we follow the arrow, and the first level that we have on here is a 1s. So 1s, how many electrons do we have for a s subshell? It's 2, right? So we put 2 on top. So then we go down, we go up again, we follow the arrow. The next sublevel is the 2s. So 2s, we know that per each s sublevel we have only 2 electrons, so we put 2 on here. We still are missing more electrons to get to the 16 electrons for sulfur. So then we go down again and we go up to the next sublevel, which is 2p. So 2p. How many electrons can we have for a p subshell, or for a sublevel of p? 6, right? So then we go down, and the next subshell is the 3s. So 3s, 2, right? How many electrons are we still missing? 4 electrons, right? Because 2 plus 2, 2 plus 2 is 4, plus 2 plus 6 is 10, plus 2 is 12, right? So we are still missing 4 electrons. 4 electrons, sorry. So the next sublevel following the diagram is the 3p. So we put 3p, 4, right? Because we only need 4 to get to the 16 electrons that we need for sulfur, right? So if I ask you guys how many electrons how many valence electrons do we have for this structure, your answer would be 6 electrons in total. Why? Because remember that the valence electrons are the ones that are only in the highest energy level, or the outermost subshell. So the outermost subshell, or the highest level, is the ones that corresponds to the level 3 and the subshell S and P. So 4 plus 2 is equal to 6 valence electrons. Okay, so let's work in another example. So let's work on manganese. So manganese has 25 electrons. Manganese, the atomic number, remember, is 25. So if we start following the diagram in the same way that we did it for sulfur, we have 1s2, then 2s2, right? Follow the diagram. Then what it comes? 2p, put 6, right? We go down, the next sublevel is sorry, we were on here, 3s2, right? We go up, 3p6, we go down again, the next level is 4s, so we put 4s. How many electrons are we still missing? 5, right? So then we need to go to the next sublevel, and then we get to the 3d sublevel. So 3d, and we put on top the amount of electrons that we are still missing for manganese, which is 5. So remember, in this case, the number of valence electrons that we have is 5 plus 6, which is 7. So we have 7 valence electrons for manganese. Why? Because remember that the only ones that are going to participate in the to make bonds are the ones that are located in the outermost shell. So it's going to be the 4s and the 3d. But what about for calcium? Let's see calcium. The atomic number of calcium is 20. So that means that we're gonna do the same as manganese, but we're gonna get to the 4s only because we just need 20 electrons. So 1s2, 2s2, 2p6, 3s2, and 3p6, and finally we get to the 4s2. Okay, so now if I ask you guys how many valence electrons do we have for calcium, the answer should be 2. Why? Remember that we need to follow the electrons are in the outermost shell or in the highest level of energy. So you know that 4 is higher than 3. So in this case we will have 2 valence electrons. So if we compare the case of calcium with the case of manganese, you see that on here we use the highest level, which is the 4s, and then we also use the 3d. Why? Because even though the higher sublevel is D compared to the D subshell, the sublevel of D is not completely filled, because remember that for a D we need 10 electrons. So since the D subshell is not completely filled, the stability is going to be reached at this subshell, the S subshell. So we're going to need to use the 5 electrons that we have on here plus the 2, so 7. So in this case right here, we don't need to use the 3p because in the case of S, remember that we just need 2 electrons to get the stability, or we cannot find more than 2. So since this subshell is completely full, that is the highest amount of valence electrons that we can get for calcium, 2, in the highest sublevel, which is 4. If you have any questions, please ask, okay? So one way to recognize or to check if the electronic configuration that we just did is correct, is by using the periodic table. So we did a configuration of sulfur and we got that we have 6 valence electrons. So if we find sulfur in the periodic table, it's in here the number 16. So if we follow the number that we have on top on here is 6, right? So all the elements that are in the same group can only share 6 electrons in total. So the number that you see on here on top is going to represent the amount of valence electrons that we're going to have for those elements located on that group. So let's prove that we did this right. So manganese, we got the manganese only have 7 valence electrons, and manganese is the 25 in the periodic table. So manganese is on here. So we have on here 7. So we did it right. All the elements that are located in the same group can only share or transfer 7 valence electrons. So please guys, go ahead, practice a little bit more doing electronic configuration. If you have any more questions, please ask.